The end behavior of a polynomial. A polynomial of degree n has the following form. Don't be intimidated by the subscripts and superscripts. Essentially, this is just the way it looks because we don't know how long it is, what the degree is, essentially the highest power that will show up. It looks like a real number times x to a power. That's what we call a term, and it's a bunch of those added, summed together. A sub n, x to the n, is called the leading term. So a sub n is the leading coefficient. That is the largest power term in the entire polynomial. And that term is going to be important to us, the leading term, because it's going to determine what we call the end behavior. Now, we've seen polynomials quite often in the course already. If n is equal to 2, this form just looks like the following here. A sub 2 x squared plus a sub 1 x squared plus a naught. This is just ax squared plus bx plus c. However, we can't give it letters a, b, and c when we don't know how long it is. Graphs of polynomials have a couple really nice things to them. They're smooth and they're continuous. So we won't see any asymptotes, gaps, cusp, holes, sharp turns, nothing like that. It's going to be a smooth, continuous curve. So let's talk about the end behavior of these polynomials, and we're going to do so by looking at, again, a parent function we're really familiar with, x squared. X squared is an even polynomial. It has degree 2, and it's got a positive leading coefficient. That is the invisible plus 1 that's there. And we know the shape of this thing is the parabola. The end behavior here is the easiest spot. As you go to the left, it goes up. As it goes to the right, it goes up. This can be expanded upon to say, okay, well, if x is raised to any even number, while we don't know what's going to happen in the middle there, any number of things could happen, it will be smooth and continuous. But what we do know is that if the leading coefficient is positive and the degree is even, it will have the same end behavior as x squared, that is, up and up. By that same logic, negative x squared is an even polynomial with a negative leading coefficient. Its end behavior is down and down. Sure enough, if we have a negative leading coefficient and the degree is even, then the end behavior is down and down, the same as negative x squared. Next, we can look at x cubed. It's an odd polynomial with an with a positive leading coefficient. And if we convert that to, say, x to any odd number at all with a positive leading coefficient, again, we don't know what's going to happen in the middle there, we do know that the end behavior will be down and up, just as in x cubed. Finally, our last case here is, well, what about negative x cubed? That's a polynomial with a negative leading coefficient that has an odd degree. Sure enough, any polynomial following this pattern, that is, having a negative leading coefficient that is odd degree, will have end behavior up and down the same as negative x cubed. I suggest you keep these 4 examples in your back pocket for the end behavior rather than memorizing this chart. But this chart is here if you need it for the end behavior of polynomials.